One of the things we're going to start to look at next, instead of position time graphs, as this one seen here, which will show you your displacement or your position versus your time, is what's known as a velocity time graph. While a position time graph will give us information about the object's position or displacement over a certain amount of time, a velocity time graph will tell us about the object's velocity over a given amount of time. So while the two are completely connected and they're two ways to graphically show the motion of one object, it's important to realize that different information can, um, can be received from each of these, and they each have their advantages. The one thing that's absolutely critical to remember here, since this is a velocity time graph, we can't forget, and hopefully nobody does, that given a position time graph, the slope of a position time graph will give you the object's velocity. So as long as you remember this right here, that slope is going to be equal to velocity on a position time graph, the rest of this should not come as too much of a challenge. So please don't forget that your slope is equal to velocity on a position time graph, also known as a displacement time graph. We looked at this when we did our buggy cart lab. And moving forward, we just need to realize for a position time graph, slope is equal to the object's velocity. So we take a look here, we have an object. Most of you, hopefully by now, realize this object was moving at a constant rate for 1 second. You know it was moving because it has a slope, and the slope is equal to velocity. The slope is constant, it's not changing, so your velocity must have been constant. Remember, slope is equal to velocity on a position time graph. From 1 to 2 seconds, we know here that the slope is non-existent, it's 0. So if the slope is 0, our velocity must be 0. Here, if we find the slope of this line, well, the rise, it goes from 1 all the way up to 3. So the rise right here is 2, and the run is 1 second. So 2 over 1 should give us 2. So since the slope of this position time graph from 2 to 3 seconds is 2, that must mean our velocity is 2 meters per second. From 3 to 4 seconds, hopefully you realize no displacement. There is no displacement between 3 and 4 seconds. Therefore, our velocity is 0. No slope, no velocity. And here we go from 3 all the way down to 0. Our rise is negative 3. We've dropped down 3, negative 3, and over 1. So negative 3 divided by 1, rise over run, should give us negative 3. So our slope, which is negative 3, tells us our velocity is negative 3 meters per second. Now, when we want to construct a velocity time graph, we take all the information that we just spoke about and we graph it on its own axes. Instead of displacement measured in meters per time, we're talking about velocity measured in meters per second per unit time. Now, I find the easiest way to do this is to look at each section individually and construct a table. So to show you what we'll look at, well, let's look at from 0 to 1 seconds. So in the time section, the time part of the table, we'll write from 0 to 1. So from 0 to 1 seconds, what's our velocity? Well, hopefully we realize that our velocity on a position time graph is determined by the slope. So if we look from 0 to 1 second, we have a slope of 1. The rise is 1, the run is 1. So we have 1 meters per second, or 1 meter per second, and velocity is a vector, must have direction. We don't have north, east, south, or west. So if we simply call it positive, that denotes the direction that it's traveling in. In this case, we'll say positive is away from it. The next time period is from 1 to 2 seconds. So if we put down from 1 to 2, hopefully we see that the slope is 0, so the velocity must therefore also be 0. From 2 to 3 seconds, the rise is 2, the run is 1. That gives us a slope of 2. So from 2 to 3 seconds, we have a slope of positive 2 meters per second. We know it's positive because it's traveling in the same direction. It's traveling away from our original position. From 3 to 4 seconds, hopefully by now you realize no slope means no velocity. And last but not least is 4 to 5 seconds. So what is happening from 4 to 5 seconds? Well, as said before, we drop 3, negative 3, and our run is 1 second. So negative 3 over 1 gives us negative 3 meters per second. The reason I like this little table is that now we have our points. From 0 to 1, it should be at 1 meter per second, positive 1 meters per second. So I apologize, I forgot to throw my time in here. 7 seconds. So from 0 to 1 seconds, we have a velocity of 1 meter per second. So from 0 to 1, we have a velocity of 1 meters per second. And this is what it says. For 1 second, we have 1 meter per second of velocity. From 1 to 2 seconds, we have 0. So from 1 to 2, we have no velocity. Our object is not moving. And we can connect this just like that. So this is now showing us that we have some velocity, some constant velocity of 1 meter per second, because the slope is 1, and that agrees here. We're moving at 1 meter per second. Here, this graph tells us we have no motion. Well, if we look at the velocity time graph, this is also telling us our velocity is 0. From 2 to 3 seconds, well, we know from 2 to 3 seconds, our slope was positive 2, so our velocity must be positive 2 meters per second. So from 2 to 3 seconds, we have a velocity of positive 2 meters per second. From 3 to 4 seconds, you guys hopefully see here that we have no velocity. So from 3 to 4 seconds, we should have 0 velocity. And we can connect that as shown. So again, this is telling us motion, no motion. We have no velocity. Here, the slope is greater, so we should have more velocity than we had previously, because the slope is steeper, and slope tells you the velocity on a position time graph. 3 to 4 seconds, again, no slope, no velocity. And from 4 to 5 seconds, we calculated the slope, which gives us the velocity over here. We know it's negative 3. So from 4 to 5 seconds, actually, if you realize I made a mistake, we should extend this down, put in negative 3. So realistically, from 4 and 5 seconds, we should have a velocity of negative 3. So here we have our velocity time graph for the given position time graph. And if you look how they're lined up, well, we have some constant velocity. We have no velocity. We have some higher positive velocity. We have no velocity. And here we have the steepest line of all, but it's negative. So what we wind up with is a negative velocity. To give you one more example, just so you guys can get some additional practice and some resources. I'm not going to go as detailed in this one, but if we take a look here, for 1 second, our slope is, the rise is 2, the run is 1. So for 1 second, or from 0 to 1, we have a slope of 2, which will translate into positive 2 meters per second. From 1 to 2 seconds, we have no slope, meaning we have no velocity. From 2 to 3 seconds, well, we drop from 2 to 1, so our rise is negative 1. Now our run is 1, so negative 1 over 1 will give us negative 1 meters per second. And that is from 2 to 3 seconds. From 3 to 4 seconds, we have absolutely no slope, meaning we have no velocity. From 4 seconds to 5 seconds is actually the same slope as from 4 to 6. So we can actually say from 4 to 6 in one active motion, well, the rise goes from 1 all the way up to 3, so our rise is 2, and our run is 2. So rise over run, positive 2 over 2, should give us positive 1, which means our velocity is positive 1 meters per second. Last but not least, from 6 to 7 seconds, when we drop from 3 to 0, that gives us negative 3, the run is 1, rise negative 3 over run 1, negative 3 divided by 1 should give me negative 3 meters per second. So now that I have my nice little chart, all I have to do is come down to my velocity time graph and say from 0 to 1 second, my velocity should be 2 meters per second. So from 0 to 1, I should have 2 meters per second of velocity. From 1 second to 2 seconds, I should have no velocity. I have no motion during that time. From 2 to 3 seconds, I should have a velocity of negative 1. So from 2 to 3, negative 1. From 3 to 4, I should have 0. There's no motion during 3 seconds to 4 seconds. From 4 all the way to 6, it's a constant positive 1 meter per second. So from 4 to 6, I should have 1 meter per second. And from 6 to 7 seconds, I should have negative 3. So from 6 to 7 seconds, I should have a constant velocity of negative 3. And I can connect these as shown. So if we take a very quick look, we have some somewhat steep constant slope, which gives us somewhat high constant velocity. There's no slope, there's no change in displacement, so I have no velocity. There's negative velocity, not as steep as before, so while I have a negative velocity, it's not as high as before. It's only 1 meter per second. 3 to 4 seconds, I have no velocity. From 4 to 6, even though the line is longer, it's not as steep as this initial line, so it should be longer in duration, but it shouldn't be as high in magnitude as my original velocity. And this line here has the steepest slope of all, meaning you cover the most displacement in the shortest amount of time, which gives me the largest magnitude of velocity, but it's negative. So hopefully this helps. We'll do a little bit more on this in class, but I did want you to have some examples, so good luck.